Good. Now let's start the discussion. All right. All right. So last time, hi everyone. Are you able to hear me clearly? Great. Great. All right. So till last time we talked about how to store the data and how to. All right. Yes. All right. So why do we need partitions? That was the discussion topic today. And for experimenting on with the Hive, you can actually go to Hue, log into h1.cloudxlab.com colon 8888, and then you can go to Hive. All right. From here, you can type your command and then click on execute. It will give you the result. Also, you can take a look at various tables which are there already and see what the columns these tables have. Okay, so this is another editor from Hue which helps you execute Hive queries. All right, now coming back to our discussion. All right, so do you have any questions before we move on? Okay, okay. So Anand has issues in Big. All right, I think I got your email. I haven't been able to reply to your email. All right, let me try to reply to your email. All right, unable to download the zip. Okay, okay. So maybe that. All right, download the zip as in. Just give me the screenshot and let me try to do that. Okay, so pick this one. Recording of the last session. Recording of the last session is here. Today is 21. This is new one. So this one is the recording of the last session. This one, you see that? All right. So this is recording of the last session. That is a question from Srinivas. Anand, I think your question, which is in email, is related to something else. So could you just drop me an email? I can reply to your email individually regarding not being able to download this. I'll also give it a try and then let you know. All right. Great, great. All right. Now, Rohit's question is, in stub test for word count, what should be given in the reducer for iterable long writable values? So in step test for word count, okay, what should be given in reducer for iterable? You mean this data type? All right, all right. I think that would take a considerable amount of going back. So why don't we plan a discussion and what should be given in the reducer? Let me discuss it after this class. Okay. All right. So great. Those were the questions from the last time. Now, till now, we have discussed about how to load data into Hive. So loading data into Hive is pretty straightforward. First, you create a table. Either you define a location or you don't define a location. And then you say load data local in path this. All right. In case your data is separated by something other than control A character, you generally mark that as here. Okay. So, so, so Hive also expects your data to be separated by new records to be separated by new line and fields to be separated by control A. In case your data is separated by something else, you mention in create table. And then you say load data. If your file is in the local directory, I hope everybody is clear about local folder and clear about the hdfs folder. So if your data is local, you can do this. Or if your so if your data is local, then you can do this. You say load data local in path this, override into this particular table. All right. And if your data is not local, is in HDFS, then you can say you can load the data in this fashion. Okay. All right. So you can say simply without the local keyword. That way you will be able to load the data from HDFS. Once you have loaded the data, then you can start querying on the data. In case you, so the data is either located in apps Hive warehouse on HDFS. So whenever you don't define the folder for for Hive, okay, if you don't define the location, it it moves data or copies data into app's Hive warehouse location. So when we are saying load this data, it is essentially copying the data to Hive folder. In case you are saying Hadoop data and you're loading from HDFS, it's essentially moving the data to that folder. All right, and so I hope the location of Hive table is clear to all. So Anand's question is, when we load data from a file into a table, number of columns in the table and file should match. That's right. All right. Okay, so if you want to save partial data, let's say you're querying the table and you want to save this part of the data, you can simply say um, insert override into directory and give after that give the query. Okay, so it will save only CMC file in your local directory. In case you don't put the keyword local, then it will save in HDFS directory, right? All right. Now, question from Srinivas is where Hive database is located. Okay, first let's understand what do we mean by Hive database. Hive database means meta store plus actual file. Okay, so meta store is in MySQL, while actual file the actual file is located in HDFS. Now, when something in HDFS, then it is okay. So then it is basically your name node plus data node. All right. The other thing we should note is 15th November. Let me just save this file. All right. So this is the location where it is stored. Also, it has something called Hive Server 2, which is running on one of the nodes. Okay, the one which is responding to our queries. Make sense, Srinivas? Great. Now, we are going to talk about an important aspect. So, more often, your data is located in multiple files. Imagine this, you are gathering lot of records continuously every day into different files. The file name is based on the certain pattern. Also, from time to time, what you want to do is you want to keep a single view of the whole data. Okay, you want to keep a single view of the whole data, as well as you want to be able to query part of the data quickly. So that's where partitions come. So in case your data is located in hundreds of files, or you want to keep the data in hundreds of files, in those cases you create partitions on your table. Okay, so you can divide the partitions of your table. And when I say partition means the file where all the records related to CMC are located. Okay, imagine that in our previous example where we loaded the New York Stock Exchange information, had there been one individual file for each stock symbol, in those cases we would have used partitions. The other important aspect of partitions is it avoids full file scan. So if you are saying select star from this where column equals to this, so it will only scan the partition where the data is located. Okay, so that avoids the full file scan. Next is you have to define the partition using partition by in create table. Okay, so while creating the table you have to mention that this table is partitioned and it is partitioned based on a column. Partition can happen on multiple columns. You can also add a partition later. Okay, you can also add a partition later. All right. So let me give you an example that will be a better idea. Let's have a look at this particular file called the amp. Okay. And where is this file located? Let's open the file browser. You could go to the query editor in the query editors and here Hive. All right. So here go to the data folder. Under data folder, you see the amp file, correct? It has got these two datasets, Sandeep Sravani and something else. Now there is another file which is the amp in the amp1 in which again the same data, uh, two more records, you can think of it like two more records, or all right. So these are the two files we have in HDFS. One is this, other is the one. Okay. All right. So let me just modify it to something else. All right. Now, oh, I can't edit it because I'm just a user. Never mind. So it's not much required. So when we look at the partition, so we have one table called the amp. Let's create a table to represent this. Okay. Let's create a table to represent this. So we have created a table called employees. Select star from employees. It doesn't have a record yet. All right. So we have just created an empty table. It says create table employees. Name is this. Salary is something. Degree is something. Then partition by a particular column. Okay. Partition by fourth column called qualification. Okay. And so this is a fourth column other than the third one. So, and there, once we have created this table, now let's load data. Now, when we load data into this table, we have to explicitly specify the name of the partition. Here we are saying load data from this file into our table, and we are defining one extra column value called qualification equals to 1. Okay, so also as we do this, load data into not local, let's say in path into the table, and let's just say data hive. It is trying to move this file, so that's why it's giving error. Okay, and where is select star from employees? Okay, it could not load the data. Never mind. So I think what we should do is we should just copy these two files into our home folder. Okay, can we copy these two files? Actions, copy to our home folder. Okay. Alright, so I've copied that into our home folder. Now we can say load data in path. Now why I'm not saying local? Because the data is in our home folder. Alright, we will take care of this question later. Let me just try to first. What is my home folder, by the way? My home folder is this one. Are there the two files we were talking about? Yeah, there are these two files I was talking about. And so let's just try to specify as this. Okay, so we are loading the data into a partition called qualification equals to 1. All right, all right. So I think I've imported it twice. Now we are saying that for qualification equals to 1, this is the data. So there'll be three columns loaded from the file, while fourth column called qualification will be set as 1. That's what it means. All the data of this will be loaded into employees table, and the fourth column called qualification will be set to 1. All right. Next is that we load the data from the another table. Again, we have to make a minor modification where we are loading this into, see that? So we are saying load data in path this into this table, okay, where qualification is 2. All right. Now let's have a look at select star from employees. Now here's the important aspect. So you can see that there are 4 columns now, while the fourth column here called qualification is a column on which it's partitioned. So these two records are coming from one file, these two records are coming from another file. Okay, and to check where is our file, you can go to apps, warehouse, hive, app, apps, warehouse. What was that? App or apps? Never mind. Okay, so let's just go to that folder. Apps, Hive, Warehouse, Employees. So this is where it is storing the data. Now, do you see something important? So it has created two folder. One is called qualification equals to 1, in which it is stored all the file which we have saved, and in the second folder it has created this. Now the important aspect to understand is that whenever we are loading data into employees table, we are basically creating more and more partitions and adding them. What is the benefit? Then when we require subsection of this data, we do not have to go through the whole data. It will only pick up the those files in which the data is lying. So Dilsat's question is that the fourth column does not exist in create table. It does, just that it is inside the partition. Okay. All right. Srinivas' question is when you load files from HDFS into Hive, understand the file getting moved from HDFS, which copy of replication is getting moved in this case, or all copy. So whenever we move the file from one location to another, actually nothing gets moved. Okay, it's just the renaming of the file happens. Okay, just like if you are in C column of your computer, and if you cut paste something from one folder to another within the same drive, nothing moves. It's just the renaming operation that happened. All right. Anand's question is it not possible for to partition the table based on an already existing column, say partition or degree? So let's say if there is an existing column, existing table, and what you want to do is maybe split the table into parts automatically. That is something not there yet. So Anand's question is it not possible to partition the table based on an already existing column and then and say partition on degree? Not yet. Not yet. As per the current version, they haven't done it. There are some maybe some technical glitches in getting it done. Okay. All right. So here is a Srinivas question, follow-up question that the renaming of file happens on all replication of copies. Yes. So it doesn't matter. Actually, the renaming operation does not have anything to do with data nodes because it is just metadata operation. Okay, it is just metadata operation because it just have to update that okay this file is now called this or this file is now in this particular folder. Correct. For each table, do we need to nominate a partition? No. If your data is in a single file, then you don't need to. All right. So this is the way we were able to load multiple files into a single table. Although under the hood, as we can see here, these are located at two different places. Okay, you can see that. Now, what if it is partitioned on multiple columns? What if it is partitioned on multiple columns? In those cases, let's say, had it been partitioned on multiple columns, there would be there would be many folders inside one another. For example, the let's say it was partitioned on these three columns. Okay? Let's say this was partitioned on these three columns. The kind of folder structure it will create internally is this. All right. For each of the values of these three variables, it'll keep on creating the 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 various. Can see that? So it'll create that kind of partitions. Okay, 2, 1, and also you could see 4, 5, 6, and so on. All right, and also you can imagine that for month equals to 1 and so on. There'll be so similarly for each year you will have all of this. All right, so for each year you'll have, for you'll ha so you can see that you could create those many partitions. If you have stored the data per day basis, then you will have these many locations. All right. So it'll be, if you are 10 years data, 10 into 12 into 30. That's what you will have. Right. All right. So there's a question from Rohit. All right. Now, question from Rohit is, so it means the data will be at a single place and we can either query Hive table or access. Yes, that's right. All right, that's correct. So the data will be at the single place. Whether you query this data using Hive or you can directly go and access it. Now, Anand's question is, if the new data is appended into employees table, how to do that? Means how will it decide it goes into partition? Again, when you append the data, you will be using load command. And when you use load command, then you will have to specify the column name. Okay. And when you do specify a column name, then it will go to that particular folder and put one more file in there. All right. Then put one more file there. Let me try to execute this twice. Oh, it has already deleted the data. We will have to load this data again. Copy the data again. Okay, let me try to copy this data. Action, copy to home folder, and that's it. Okay, copied. Now let me try to execute it again. Alright, I think it has done the job. Select star from employees. Yeah, you can see that for partition number 2, there are two more records here now. Right? There are two more records here now. And under the hood, it has basically copied the new data into the warehouse again, and you can see for qualification number 2, you can see that there are two files now. Is that what you're looking for, Anand? All right. Next question is from Dilsad. Once the data is loaded into data in pa- so once data is loaded, is data in partition is still represented in HDFS but represented as table. So it is present in HDFS and also represented as a table in Hive. Okay. So this is where whenever you create a Hive table, the data is created. If you already have a Hive table and you don't want to load it, you can simply create Hive table at that location. All right. So that was a idea about partitions. Now, in table, it on tables, Hive provides you the complete flexibility of various various is structure related to DDL, as in data definition language. So you can alter the table like this. You can say alter the table and rename my column to this one. Sorry, rename the table to this. So if you want to rename a table, it's very straightforward. You can do that very easily. Then second is if you want to alter the name of column, you can do that. Also, you can add more columns to it at later point of time, and then then load the data again. You can also drop a partition at later point of time. When you drop a partition, the data might get deleted from the from the storage. Okay. So if your file is internal table, the way we have created here, and if you drop the table, the data will get deleted. But if your table is external table and you drop the table, nothing will happen to your data. Data will remain in the HDFS. All right. So we can simply create an external table. Right now, if I delete my table, let's say you have this is where my warehouse is, right? This is where the data is. If I delete this table, what will happen is if I say drop table employees, it will also delete all these folders. But sometimes you don't want that. You don't own the data. Therefore, you may want to create a external table. You may want to create an external table. And when you create an external table, you define the row format, and then you define the location, and you basically rest of the operations in case of external table are exactly like our managed tables. All right. Sometimes you may want to, so you might ask that what is the benefit of external table? You can create an external table on remotely located data, remotely located read-only data, such as your table might be in S3. S3 is Amazon's way of storing data. You can buy an account with S3 and you can store data there. So so you can basically create an external table in S3. All right. So also you can create an external table partition, and the beauty of an external table partition is it could have partitions from remote. Okay, so you can imagine that, let's say you have been running your operations for quite some time. In first year you had put your data in S3. In second year you started putting the data in HDFS. Now this external table can have multiple partition, one pointing to S3, other pointing to HDFS, other point maybe pointing to a network file system. So that is the important aspect about external table. Now, external partition table. You can see that here we are saying alter table and add partition this at this location. Alter table this, add partition this. Okay. And here what exactly are we saying? In case the location of a particular partition changes at point of time, at later point of time, we can modify that too. You can see that everything remains same. We can alter the table location. All right. We can also ask for describing a particular partition. Okay. In our case, that the same thing will translate into describe formatted employees, and I can say here qualification equals 1. You can see that it has given us all the information that we need to know about the data. All right. So if external table is dropped, data will still be in Hive. So if external table is dropped, data will remain where it is. Okay, data will remain where it is. It won't change the folder. It won't delete. Okay, but metadata will be deleted. So when you come to Hive, you will not be able to see that data. Good. All right. Now going ahead, and so again, as a quick recap, each table has got a location. By default, that table is a directory under the location, under this particular location. But okay, and you can override that location by mentioning location in the create table clause. So whenever you're saying load data, it copies the data if you are loading the data, if you are loading the local data, it will copy the data to HDFS and then put it under that. And but if the load data moves the data, if it is on HDFS, for both external as well as managed, dropping managed table deletes the data at the location. Deleting external table does not delete the data at the location. Now, the metadata which is stored in the relational database, okay, is in Hive is called metastore. Okay, so generally it's the metastore is generally MySQL in our case also here. All right. So you can have complex statement like this in case you want to do computational on the columns. You can have a complex statement like we are calling a function on a column. Second, we are accessing upper deductions, which is a map. And then you are doing round salary into 1 minus deductions this. So basically, you can do very complex operation on the table. Also, you can have aggregations on a particular table. You can see select count star average salary, sum salary from employees. All right. So yeah, there's a question from Srinivas. What are the criteria to choose internal versus external? The generally keep everything as external table. Honestly, okay, keep everything as external table unless you want the data to be deleted at the end of the whole process. Okay, but I would say that keep things in external as external table always. All right. The question from Rohit is, what is deduction in last slide? Deduction is some one column of this table which is of data type called map. As we discussed in the beginning, that every we can have a complex data type like map. All right. Now we can have aggregations, and sometimes some of the aggregations take the benefit of doing it over the map site itself and avoid avoid the reduce phase. For example, count star can be done on the map site itself. Sum, count star, average, all of this could be done on the map site itself. So in those cases, you can tell Hive explicitly that take the benefit of map side aggregations. Okay, and it will start doing the map side aggregations. All right, this there is a very important concept called views. So whenever we are creating table, we are actually storing data in each table. What if what if our SQL query which we are using to churn these tables, whatever SQL query we are using, it becomes complex. It becomes complex. Then, in those cases, you can break down your query into views. Similar to in what we did in Pig. In Pig, we had one data set representing each step, right? So that kind of data set were nothing but views, because every time you query a view, it's going back to execute all the tables or all the clauses which have resulted in this view. For example, here we are saying create view tweet underscore clean as this particular query. Okay, from here to here is the query that tweets underscore clean represent. So every time we will say select star from tweets underscore clean, it's going to execute this particular SQL. Every time we are going to say select star from tweets underscore clean, it's going to execute this query. And if we say select star from clean where ID is greater than 20, then that clause is going to be part of this query, is going to be executed on top of this, and that those particular conditions will be applied. Okay, so this is a very important aspect of views. So this complexity on how do we how did we reach to tweets underscore clean is hidden from us at later point of time, or for others it's hidden, or our life has become really really easy. Rather than trying to get everything done in a single query, we can break down a big query into small parts, and also reuse those views in different queries. Okay, so you can see that this is how we will be calling this. See that? All right, now that was views. So we can also create custom functions. If you want to create custom functions, we can create custom function in Hive like this. Let's say just like Pig, we can create custom function in Hive as well. So exactly that way, we extend UDF, and then after we extend this UDF class, we have to implement a function called evaluate. And inside the evaluate, we can return the value whatever we want to do. Okay, so this is how you create a custom function in your in Hive. And also please note that once you are done with creating custom functions, you can create your jar and copy to the server, add jar to your folder. Okay, so right. All right, so once you have created this class, once you're done with it, you can export that as jar, and once that jar is done, you copy that jar onto the server either by the way of SCP or WinSCP, and then you add your jar and execute it. All right, so afterwards you can basically call your function like this. Okay, you can call your function like that. All right, next is, yeah, all right, sometimes loading data. And also this, if you want to try it out, this Hive example, you can try it out from the LMS. All right. So sometimes you want to load the JSON data. You want to load some complex data. In those cases, you could download JSON Survey and then start using those. Okay, so again, let me take a step back. When we said load data into our table, it expects the data to be separated by new line, and it expects the data to be formatted by a field separator called control A. We could customize it a bit so that it could load the data which is in tab separate format. But sometimes your data is far more complex. Sometimes your data is fairly complex. Say, for example, your data is in XML format and you want to load it as a database table, or your data is in the form of JSON. JSON is a complex format. It is basically JavaScript object notation. So it can have object under object and it can have up to any level. Okay, so if you have to load that kind of data, you cannot use simply load data into my table. Instead, you will be using the third party libraries called Serde. Serde represents SERDE. Serde represents serializer and deserializer. All right. Serde represents serializer and deserializer. And once you have Serde in place, you can load Serde into by saying add jar and give the location of that jar. Okay, you can give the location of that jar. All right. So that's okay. Anand's question is: can a function be based on Hive queries and alone, other than using Java? No. The UDF can be created either in Java or Python. All right. Now there's a question from Dilsad. Where do we put the jar? Let's try to put this jar. Let's say I think we have a folder here. Yeah. For example, let's say we try to add this jar. All right. Let's say we want to add this jar. How will we add this jar? So if we go to Hive editor and say add jar and say hdfs, will it take it? I think it is working. Yes, you can see that. So this can be in the hdfs. Should we try our example? Let's go to very good question. Thank you, Dilsad. Let's try to do some things like where is my Hive folder? Is this our Hive folder? Let me just import the Hive folder existing project into workspace, and we could go to all right. It's not there. So as the test, we what exactly are we trying to do? We are trying to find out the table. All right, I think we'll have to download it from the example here. Hive UDF example, Hive UDF steps. The project is here. Alright, so we are downloading this zip file and then see what happens. Alright, yeah, it's downloading now. This is the one which we are downloading in the session number 6. It is here, this one. Alright, let's try to go here, browse, and first clear this up. Let's say delete, import existing project into workspace. So what we have done, what we are trying to do, we are trying to see if our UDF example would work or not. So for that we have first downloaded the project and unzipped it. It is located in my downloads folder, and then we are going to the downloads folder, and under the download folder there would be, yeah, you can see that here. I could say finish, and there is my download folder. Alright, here let's check the reference library. It is able to find our reference library because it's in the same folder there. Okay, now we can comfortably say file export, and we could say here in the download folder again hive udf.jar. Okay, now go back to the file browser, and in the home folder let's upload the recently created jar file. Okay, also we forgot to go through the example we are talking. So here in this project big not did we do the export on right one? I hope we did the right one. Okay, so here you can see the Hive examples under SG. So there is a function called lower, and the function, for each function which you want to create in Hive, we have to create a class that extends UDF. So this is the name which we have given with for our function which we are creating called lower, and then we have to define what exactly it does by creating a function called evaluate. So this is our code. This is our code. All right. So all it's doing is converting it to lowercase. So we have put it somewhere here. We have to put it somewhere here. So we just click on upload. Okay. And again, here is getting uploaded. And let's see if we can uh, use this command now. All right. If we can say add jar, and we can say hive udf.jar, hive udf.jar, and what were the other commands in here? We are saying create this. Okay, create this and select this. All right. So we are basically saying that create a temporary function my lower, which is alias of this my package name and Java class name, and Java package name and Java class name, and let's see if it runs. Failed to read external resource. This is correct. Why it's giving an error? Illegal character at the 0th place. This is oh, I got it. I got it. We are doing stupidity. Alright, so it has to be like this. Okay. So it says class SG my lower does not is not found. Is that wrong? So let me just have a look at what's going on here. This is correct. Yes. Is it like this? All right. Thank you, Rohit. Thank you for helping me out. Yeah, it was just this mistake. All right. Good that we are able to do this. All right. Let me also correct this script here so that we don't make this mistake again. All right. And temporary function is this. All right. Good. Thank you. All right. So let me do a recap for those who got lost in my. Okay. So here are the things which I did. All right. Here are the things. Let me do a quick recap of what I did. First, I downloaded this project, then imported this project into Eclipse, and after that I created the jar, which means compiled and packed into a kind of a zip file. So this is the jar which we have created. After that, I went to the file browser and uploaded it in my home folder. Okay, note the location. This is slash user slash this And then also note that here this jar is located in HDFS. That's an important aspect. And while when the jar is located in HDFS, you can say things like add jar HDFS colon slash 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 user this. Okay. And then we created the temporary function. And after that, we said select my lower this. Okay. Does that make sense to you? All right. Yes, thank you, Anand. Thank you for helping me out. Yes. So Dilsad, yes, Hive UDF is in the home folder. Semicolon. Thank you, Harita. Okay, that's correct. Yes. All right. I should have seen your question earlier. Okay. So Sumati's question is, mm, okay. So Sumati's question was maybe the error was because we had three slashes, but I think that's okay because one slash is for user because our location is actually absolute location in HDFS is this, and double slashes are for the protocol. Wow. All right. Okay. So I everybody got the thing that it's about sg.lower instead of sg.mylower. It's just that I was missing that point. Okay, so there are so many questions, so many answers for that. Good. Thank you, Pankaj. Thank you, Dilsad. Thank you, Srinivas. Thank you, Sumati. Thank you, Anand. Thank you, Harita. And yes. Okay. So there's a question from Dilsad. Question is, okay. Question is, do we need to do the add jar command every time we use this function? So do we need to do give add jar command every time we need to use this function? Interesting. So add jar command can be used every time when you are using external function. And in this case, in every SQL, whatever we are doing, if we are going to use this particular function, we have to specify in the first line. You have to specify that in the first line. All right. So that was our struggle with defining the UDF. Okay. And the reasoning for behind this struggle was that probably we are doing it for the first time through the web browser. So far, we have been doing it from the command line. All right. So, but luckily, the interface in the UI here is actually quite clean. It's actually quite clean. So, it's good that we use the web interface. And I think it's completely okay to use the web interface. All right. Now, also, please note that if you are logged in from console, although the console is not doing great because console is this is console, okay? Here you could say register and then it won't have to look for it won't you won't have to specify HDFS colon colon. Okay, if your file is located in local file system, then you can simply say add jar slash my folder slash some folder. Okay, you could say that. Sounds good to you? I hope everybody will be able to try Hive. All right, so here are few important aspects about order by and sort by. So in Hive, it is started with order by. Order by means, when you say order by, it basically orders all the values of that table based on a particular column. So it orders the rows of a table based on a column. It gives that result. It doesn't change the behavior, it doesn't alter the data of the table. It just gives you results sorted by that particular column values. Okay. So it guarantees the global ordering. Okay. And it does this by pushing all the data through a single reducer. The default construct provided by Hive for order by is only for only it can only do this through single reducer. So this is not acceptable when the data size is huge, because one single reducer cannot suffice. The whole time will be taken by reducer, and one particular machine will go very busy. So the whole idea about distributed computing goes waste if there is a single reducer and the data is used. Therefore, therefore you therefore you cannot use order by sometimes if your database table is really big. So that's where the idea of sort by X came into play. Now, sort by X basically uses multiple reducers, and each reducer can receive overlapping ranges of data. So you can specify number of reducer in the construct itself. You will end up with n or more sorted file with overlapping data. So if you remember our problem statement earlier, when we were doing word count, remember when we were doing word count and we specified more number of reducers, what happened? We got two files. We defined two reducers, right? And we got two files as our output. And when we got two files as output, okay, when we got two files as output, if we concatenated them, we did not get the right results, because both of those files individually the data was sorted, but they were not. So data was kind of ranges were repeated. So first one will also have the words with A, B, and C, and second one will also have words with A, B, and C. Okay, so let's say first one is having A1, B1, C1, and second one is having A2, B2, C2. When you concatenate these two files, the result is not ordered. The result is not ordered. Why? Because the result will look like ABC followed by A1, B1, C1, although individually both files are sorted. Therefore the idea of sort by X was not successful. Let me take a step back once again. So when in our word count problem we specified that there are multiple reducers, it created multiple files, but but those files were having overlapping ranges. Therefore, if we concatenate the data, it wouldn't it wouldn't be ordered. Therefore, Therefore, simply providing a multiple reducer did not solve the problem. Therefore, this sort by X also did not solve the problem, because here we said that we want output which is ordered by this field, and we want these many reducers. Sort by X basically specified number of reducers. Okay, it tries to solve the problem of order buying, but that is not good enough. That's where the another construct they introduced called distribute by X. Now, when we say distribute by X, we X is a column. So based on the column, the values are splitted such that ranges do not overlap. Ranges do not overlap. And this distribute by X basically uses the partitioner under the hood to make sure that the ranges do not overlap. meaning the partitioner will make sure that A1 will go to the same machine, while B1 and C1 go to the second partitioner, B1 go to the second partitioner, and C1 goes to the third partitioner. So this way, that partitioner, uh, sorry, third reducer, I mean to say. So partitioner made sure that the keys that go to the two reducer are non-overlapping. The way we did earlier, that if my word is starting with less than or equal to j, send it to first reducer. If it's greater than or equal to j, it send it to the second. So basically, based on the based on the partitioner, we can make sure that the ranges are non-overlapping, and that's what distribute by x do. But we'll have to combine and distribute by x and sort by in order to get the correct results, and that's where cluster by x comes in. So cluster by x is equals to sort by x and distribute by x, meaning having partitioner as well as multiple reducer. So sort by x means multiple reducer, distribute by x is having partitioner, and cluster by x is both. Okay, so it ensures cluster by x ensures that all the n reducers get non-overlapping ranges. Then sort those ranges at the reducer. This gives you the global ordering. It is equal to saying distribute by x and sort by x. You will end up with n or more sorted files with non-overlapping ranges. So you can later point of time you can simply concatenate them and get the results. And cluster by x is basically um, more scalable version of order by. Okay, so you can create a table like this and also say cluster by x into 32 buckets, meaning there will be 32 reducers and the data will be ordered by this. Sounds good to you? So this is the syntax for cluster by. So we can define it by in the beginning itself while defining a table. All right. So here what we are trying to do is we are trying to create a table for the data which is movie lens data. And this movie lens data is located in, do we have this data somewhere? Let's have a look at the data folder. So you can see the data is here. So we have movie lens data for this exercise. 100K as well we have here. I've already downloaded the data. If you want to download, you can basically use wget command. Wget is the one which can download the file. You can either download on your desktop and upload it via the Hue browser and then query the data, or you could use this particular I mean our table. So here we are saying create table u underscore data, and we are defining that here. We are saying create table u data. These are the columns, and the row is formatted by uh, r- okay, and fields are terminated by a tab, and stored is as text file. Okay, so when we have this, then we can, here you don't have to specify local. Instead, we can say home, or let it be local because it is going to ask. All right. So this is the data which we are trying to do, or we can say create external table and create external table, and we can say location. So there are a couple of ways to do this. Location, and where is the location? Probably, let's say, which table are we trying to do? U underscore data. We are trying to say U dot data. We U dot data. This one. Okay. Let's see. I'll say let's just copy it to our home folder for time being. Action. Copy. Copy it to our home folder. Why am I doing this? Because if we try to create an try to when we'll try to load it, it will ask for it will try to rename move this file, because as I'm telling you that if you try to load the data from HDFS, it will try to move this. Okay, therefore we don't want it. We don't want that. So we have load data, remove local from here because it's not in local directory here. This is the location of our file, and this one, let's just copy it from the URL, and we saying load data in path, this overwrite, and then the into the table name this. Okay, so we are loading data into our table. What does it say? It says that you cannot do this. Oh, right, you're right. So we'll have to go to. So this is the reason. This is the error if you try to create, try to load HDFS file which is not in your control. Therefore, we have copied this into our home folder. Okay, that's the reason we copied this file into our home folder. Now let's try to do load data in path this into the table which we created earlier. Okay, so the table has been created. You can see here. All right, you can say select star from U underscore data limit 10. You can see the data has been loaded into the table. Also, while we have loaded this data, the table would be deleted from here. That file would be deleted from the HDFS. Okay, so we were able to successfully load the data. All right, so this is a question from Anand. Question is, this syntax is used while creating a table which is nothing but only storage. But the number of reducers will be decided by actual logic, right? So generally we have the idea about how big the file is going to be. That's where we can define the cluster. Okay. And here it's nothing but the storage. Yes. So you are right. Now Dilsal's question is the U underscore data is now under this. Yes, it has been moved. The moment we said load, it has been moved from your home folder to warehouse. Okay. Carlos's question is it similar to SQL DR with many parameters? I am not sure about SQL DR. Srinivas is saying from where are we loading data, local from or HDFS? We are loading from HDFS because we are interacting with Hue here. Okay, we are interacting with Hue. That's why we have removed that that particular clause from here. You see that we removed, if you see, we removed this local from the keyword, and the query became like this. Okay, so if you want, I can give you that load command. All right, great, great set of questions. All right, so that was how we did our quick querying. Here are two assignments for all of you. Okay, here are two assignments. For each movie, how many users have voted for it? And for movies having more than 30 ratings, what is the average rating? All right, is the question clear to all? Okay, so select star from u underscore data group by movie ID. Okay, and we can say movie ID comma average rating. So this will give us the average rating for each movies. So it's running the map reduce. All right. So now it has successfully finished the job. You can see that for each movie, it has given us the ratings. All right. Now you can join this table, the result of this table, with the other data which is lying in the same folder. If you go into the same folder, you can create here. This is the folder which we are operating upon. You can create you can create the external table that's pointing to u.item, where what does u.item contain? It contains the ID of the movie, name of the movie, release date of the movie, and then IMDb URL along with other aspects. Okay, so you can create another table where the values are pipe separated, an external table, so that you don't have to copy it and load it. So you can simply create an external table and you'll be able to use that. And then you can join that table with this result and quickly see which movie is rated average how much. Okay, the only problem with this is that in our average approach, where we are doing average, if there is only one person who has watched the movie and rated it like 5 out of 5, the numbers might go skewed. Okay. Therefore, therefore, assignment to all of you is, give us ratings for all those movies only which has at least 30 ratings. Okay. So Harita is saying, what if you create table on an existing folder? I think that's what you're saying, Harita. So if the files are already in this, and do you still need to the answer is no. If the file is already at the location where you have defined, then you don't need to load. Or the interesting part is, you can yourself copy the data into that folder and it will still work. Okay, you can yourself copy the data. Instead of loading again and again, you can actually copy into HDFS, and then I will happily accept that data as the input. If the format is not correct, then you can, it will reject or give the error. Okay. Yes, good, good, Harita, that you're using in the same way already. Brilliant. All right, let's take a break for 10 minutes and back by Hi everyone, I'm back. Should we start now? All right. All right. So the next thing that we are going to start is very important. Yes, Carlos, are you able to hear me? So Rohit's question is bucket defines the number of reduces invoked when table is accessed. Yes. Okay. All right. All right. Great. Let's start. Yes, we need to define the buckets to use the cluster by. That's right, Rohit. All right. All right. So we are going to discuss something really, really important. Okay. And which is understanding NoSQL and HBase. All right. So here we go. All right. So we are going to discuss a couple of things which are very important. And yeah. So in case you have no expertise in SQL, you can say that you are an expert in NoSQL. Okay. If you have no knowledge about SQL, so yeah. All right. All right. So before we try to understand anything about NoSQL, let's understand the difference between scaling out and scaling up. Scaling out, also known as horizontal scaling, and scaling up is also known as vertical scaling. Okay. So let's take the example of a horse cart. So there was a person who has a single horse cart, and suddenly he needed to carry more load. He needed to carry a lot of load to instead of which cannot be pulled by a single horse. Now he has two choices. Either he figures out how to use two horses in the cart, or he buys an elephant and tries to fit elephant in the existing cart. Okay. So if he chooses to uh, use multiple horses, that's called horizontal scaling, or saying scaling out. Okay. So meaning if your database is under a heavy load and you choose to increase the RAM or processor and or hard disk, then you are basically scaling up. Okay. You are scaling up. You are basically adding an elephant instead of a horse. Now, in case you figure out that you can divide your load into multiple machines and you put multiple machines to cater to the user, then it's called horizontal scaling or scaling out. All right. Now, let's just walk through this RDBMS story, and this should give you a very right perspective of why we have NoSQL in the first place. Okay, so understanding NoSQL is it starts with understanding why do we need it. Okay, so let's imagine that you are a good organization or great product company, and you are launching your product today. So you move the database from local workstation to some remotely hosted workstation and a MySQL instance. And today you are pretty happy. You have created a great database schema with perfect indexes and perfect queries, and let's launch. So you launch it, and the service becomes popular and people are using it, and suddenly you are realizing that the people who are coming to your website are uh, the every request from the user is hitting the database. And so what you do is you add a caching layer. What do we mean by caching layer? Caching layer means you install something called memcached on another machines in the network, and whenever a request is coming, first your web server is checking whether that request can be catered by memcached or not. If it can be catered by memcached, then cater it. Otherwise, prepare the data, make the call to database, and then update the memcached. Memcached is a database a caching solution. It's a general caching solution. Is very frequently used with Apache and other web servers. So so your service is becoming popular. There are too many read settings. So you all you did was added a memcached. Now, sounds like a very nice thing to do. Sounds like a cool thing to add a caching. Probably every architect you meet, the first step of optimization they do is put the caching. But caching, the moment you bring in the caching, what happens is you suddenly became inconsistent. What do you mean by your system became inconsistent? Your system suddenly became inconsistent, meaning you are serving stale data, maybe stale by milliseconds, maybe stale by seconds. But the moment you bring cache in, your system becomes inconsistent. Reason is that if if there is a data change, it will take some time to reflect in memcached. Until that point of time, it will be serving the older data. Therefore, it became inconsistent. So, and that's the first thing that happened with you. And that's the first bad thing that happened because of the load. Now your service continues to grow in popularity, and you realize that too many writes are hitting the database again and again. So you vertically scaled up. You're pretty happy with this decision that you have bought this great hardware and you have put in. You have bought a CPU with 16 cores, a machine with 16 cores, 128 GB RAM, and really fast hard drives. Now, at first it will look like you solved your problem. There would not be any further issues. But soon enough, you started building more and more features, and every feature you build in, it would generally require one more join. You can imagine how would Amazon.com's website look like, right? In Amazon.com's website, on the detail page is the one where you have this buy now button. On the detail page, there are around 200 features. There are around 200 features. Okay, so so you basically there are around 200 features, and those 200 features you have to do 200 join 200 tables in order to cater. So as and when your product is maturing, more and more tables will keep coming, and therefore Therefore, you realize that you have too many joins and hence your overall response time is very bad. You are doing a lot of heavy weightlifting. So you decide that you denormalize your data, meaning you will stuff all these tables into one table somehow and make it work. Now, the moment we talk about denormalization, the DBA in you will tell that this is not what we are taught at school. This is completely wrong. But you can't help it. There is no other way out at this moment. But still, the story doesn't end here. If you do a PR or if the service is getting covered a lot and it's really useful, so it's getting swamped. The server is getting swamped by the number of requests. So things are still slow. So you quickly do decide few things. You stop doing any server side computation, meaning let's not do the server side computation, meaning we will not have stored procedures. Now, the story doesn't stop here. Some queries are still too slow, so you periodically pre-materialize those queries, meaning periodically prepare the data and put it in the cache. That is pre-materialize. Even if the users have not asked for it, you prepare that upfront and keep it in the DB. Okay. So now at this point, the reads will be okay, but writes are getting slower and slower. Writes are getting slower and slower. Reads are okay. Now, when writes get slower and slower, at this point, you drop secondary indexes and triggers. So, what has happened in this discussion? We started with the perfect world. We started with the world where we were taught how to build a great database. Okay. But then, because of the load, because of too many requests, because of the velocity of the data, we end up in this situation where we had to let go of all the features of database. We are no longer using secondary indexes. We are not no longer using the triggers. We are not using the stored procedures. We are not using any of the foreign key, primary key kind of a relationship, and we are no longer consistent, as in the acid property we had to let go of. Why? Because we introduced caching. So what you just saw is that as the velocity comes into play, as the big data comes into play, the laws change. The laws that were taught in DBA change. We realize that all these facilities provided by databases are actually stopping us from solving the problem. And even all the at the seven step, even if we do that, we will not be able to solve the problem. We'll have to go for multi databases. We'll have to have multiple instances of database, and then let part of the database get let part of the request be catered by some of the databases. So this is the reason why we have NoSQL. NoSQLs realize that we don't we can there is no point of having a really heavy database. Let it trim it down. Let's make it fast and let us make it run on multiple computers simultaneously. So why NoSQL? First answer is big data. Second answer is high availability. Big data, as in we should be able to store terabytes or petabytes of data into this kind of DB. Second is high availability. Should be able to cater to thousands of requests per seconds or per milliseconds. Third is scale out architecture. What do we mean by scale out architecture? Today we need 100 terabyte. Tomorrow we might need 150 terabyte data. So we should not have this worry that we'll have to go through architectural changes. We can simply add few more machines and it will keep on going on. Okay, so what is NoSQL database? NoSQL database is a database with distributed architecture where Since it's distributed, it divides the data onto multiple computers. So to identify each record, we have to have an identifier for the record. The full form of NoSQL is not only SQL, and it's non-relational mostly because they have because as we saw in our case study that we had to anyway let go of the foreign key constraints, so they cannot be relational. The other reason for non-relational is because data is going to be divided on multiple nodes, so the primary foreign key relationship cannot work because one part of the table is on one machine, other part of other table is on another machine, so primary foreign key doesn't make any sense. Therefore it's non-relational. It's mostly open source. Since most these are database technologies, there are around 150 databases in the industry, and since these are data oriented, meaning if let's say go to your organization and pitch, hey, we have this beautiful database, this and that. Now the first question that comes into your mind is, what if this company shuts down? What happens to my data? Therefore all the NoSQLs, if as of today, if you have to build any organization which locks in the data, you will have to open source part of it. Okay, because only then you will be able to acquire the customers, will be able to acquire the users if it's open source. Because anywhere the lock-in is there, everybody is very apprehensive about putting the data in. So most of them do not have SQL. They provide a different kind of API for putting in data in, and they run on commodity hardware. Commodity hardware is not defective hardware. Commodity hardware is an average computer which is good enough to run. It's not a very high scale system. Okay. All right. So there are four types of NoSQL data stores, starting with column oriented one. These are the most closest to our database tables. So the example is HBase Cassandra Accumular. So we will go into the detail. What do we mean by column oriented? They more look like tables. Then we have document oriented database. What do we mean by document oriented database? Document oriented database means databases in which each row or each record is formatted into maybe like an XML document, or each record is formatted in a JSON kind of format where it's a complex structure as in object within object within object. For example, here uh, every record so every record is a TV show. Each TV show has many seasons, and many seasons have episodes. Episodes has reviews, and episodes has casts. Okay. Now, so therefore, such kind of data structures where the object is really complex, keeping it flat into the database table becomes very difficult. Okay, reason is that if you try to stuff it into a single table, it becomes impossible to query. Okay, therefore you need the document oriented databases to manage this. Third is key value. Key value is the most primitive and simplest one, where we have key and value. You can imagine like a big spreadsheet having only two columns, key and value. Those are the kind of databases which we started with. And Dynamo was first example of key value. They published a paper on that. And key value exists in mostly in case of in-memory databases such as Memcached and Redis. Also, please note that we don't call these data stores as databases, because to qualify for databases you need to have lot of things, and none of the NoSQLs have those properties. Now, graph. These are fourth new kind of new generation of databases called graph databases help you store the data and process the data which is in the form of graph. Okay, so while if the data is in the form of flat file system, you have HBase. If the data is in the form of complex tree structure or document structure, you have document oriented database. And if you have the data in graph structure, graph means there are relations, complex relations, not only the top down relationships. In those cases, database like graph database will be useful to you, such as storing the relationships of the social graph. So these are the classic differences between NoSQL and SQL. And yeah, you can go through these. We've already covered all of them. So now I want to discuss a very important aspect of the whole NoSQL jargon. All right. So you might wonder that will NoSQLs replace relational databases? Will couldn't we just change the existing database to fit in to these NoSQL needs? Couldn't we do that? Okay. Or will MongoDB or HBase be able to use as the transactional? Let's try to understand. So some of the one of the researchers named Eric Brewster, after trying a lot to provide relational properties, after trying hard, he realized that in a system you cannot provide all the three things. You cannot provide consistency, availability, and partition tolerance. You cannot have all the three of these. What do we mean by consistency? Consistency means every user, all the nodes, or every user of the nodes see the same data at the same time. Okay, in our typical databases, this property was well understood. We could not imagine that this would not happen. We could not have thought of even uttering this thing that okay, we need consistency. Of course there was consistency in probably every RDMS. If there is no consistency, it's not database, right? But now after a lot of work on NoSQLs, people realize that consistency is something which we might have to let go of. So out of consistency, availability, and partition tolerance, we can only have two. What is availability? Availability means lot of users can access your server. And how can you make that possible? By having multiple machines to cater them. So the number of machines who can cater to the user, the the more the more number of machines you have, the more number of people will be able to access simultaneously, and hence more will be availability. Third one is the partition tolerance. Partition, what does it mean by partitioning? Here it's not partitioning like our the way we talked in Hive. Here partitioning means, or partition tolerance means, so you have a big network. Some machines could go down. This is called network partitioning. Some machine could shut down, some machine could burn down. So this is called in the database terms, it's called partitioning. It's called network partitioning. Now, due to network partitioning, are you able to cater to your users happily? Okay, so that's called partition tolerance. If you can, then you have partition tolerance. If you cannot, then you are not partition tolerant. So out of these three, there are many databases who fall into the category of providing two or one or two properties of CAP, and that's why it's called CAP theorem. CAP. All right, let's try to understand why is it so. Probably this diagram will make you clear exactly what's going on. Okay, this diagram will try to explain why CAP theorem is difficult to achieve. Capturum is correct, or why C, A, and P, all three are impossible. Let's just try to imagine. All right. So before we get into that, there's a question from Anand. Question is whether this NoSQL is only applicable for HDFS Hadoop or will work in other systems. So in case of HDFS and MapReduce, HDFS does not provide you record by record operation. Instead, it provides you file by file operation. So that's why we have HBase. So we'll go into HBase. All right, let's have a look at the first diagram. Also, try to imagine other kind of structures that you could make. Okay, try to imagine that. So let's start with our default one. We have one box, and we that is the one which is having our database. Users are reading and writing to the same database. Now, same box, all users are connected to. So it's consistent, definitely consistent, meaning if one user writes something and another user who comes after say half a millisecond, they will be able to see the data which the previous user have written, right? So it's greatly consistent, but it's not available. It's not greatly available because number of connections that a server can handle, number of connections that a server can handle is very low. And what is availability? Availability means that every request need to be answered, okay, whether success or failure, but requests need to be answered. So first one is not available. It's not partition tolerant because in case this machine goes down, all the users will be impacted. All right, so out of C, A, and P, the first diagram only has C. The second diagram, where you have two nodes A and B, and the architecture you designed is interesting. The architecture here is all the writers will go to A, data will travel to B, and readers will read from B. There could be C, D, E, F similar to B, meaning when the user is writing to A, the data will go to B, some data will go to C, some data will go to D, and users can read from B, C, D. So like we have A and B relation. Now what we did here is we increased our ability to provide rights. Okay, so also if there are two users who have come at a difference of 1 millisecond, the writer went to A and the reader went to B. The reader wants to read the data being written by the writer, but just after a millisecond. So it will always get the stale data. And you will feel frustrated that hey, I just wrote some fresh data but I'm getting old data. Why? Because that it's the change is taking place, and the change will take place over the network. Okay, so somebody wrote some data to A, it will take some time to reach to B, and then the user will read from B. But by the time your change reaches B from A, all the users will be reading the old data. Therefore, it's not consistent. Instead, instead, it is eventually consistent. It is available, it is partition tolerant, but it is not consistent. Okay, it is available. Why? Because some users are going to A, some users are going to B, so it's more available than the previous one. It's not. It is partition tolerant in the sense that if one of the machines goes down, you have other machines to which you can cater to. So therefore, it is fairly partition tolerance. So Anand's question is: load balancer in the current world will resolve availability issues. That's correct. That's correct. Good point. Now, moving ahead with the third diagram. This third diagram, in which all the users are writing and reading from A, and A is shifting the work to B. So all users are going to A and reading writing from A, and the backup is being created at B. Now, this is consistent because all the users are talking to A, but it's not available. Why? Because it's only one machine. The third is partition tolerance. It is partition tolerant. In case A goes down, you have B. All right. Are these three diagrams clear to all of you? Yes, Rohit. Great. Everyone? All right. So if you have any questions, you can ask. All right, great. There is one more idea called column oriented database. Column oriented database. Before we jump into column oriented database, let's try to understand how does compression work. So compression works the way zipping happen, the way you compress the data. How does that happen? Okay, the compression happens by r- figuring out a small symbol for most commonly repeated string or the biggest repeated string, and then replacing with that symbol, right? So that's a very quick way of defining compression. And if you think about it, the compression will be better if there's a lot of repetition, right? Compression will be better if there's a lot of repetition, or if there is a lot of similarity in the data. Okay, so if the data has got a lot of repetitions, the chances of compression will be really high. Okay, so you must have seen this already. If there is a single song which has got a lot of repeated lines, you can actually write it by placing dash 2 dash 3 dash 4 kind of in lyrics. So that's how the compression happen. The more the repetition, the better it is. Okay, so lots of people realize that if you take a column of a table alone in isolation and then you try to compress the data, then the results are far better because there's a lot of comparatively more repetition of the data. Similarity of data is higher, therefore the compression of the values of a column is really great. Okay, therefore some of the researchers said that let's store data column wise rather than row wise to have a great compression, to be able to store more data. Okay, and that's where the idea about column oriented database come into picture. All right, so you have, okay, you have two kinds of storage. One is row oriented storage, in which first you store all the values of a row, and then you store second row, third row, fourth row. That's row oriented. So although physically to the end user it's a table, they look at it at a table, as a table. It has got columns and it has got rows. Now it's up to the user whether they want to go with row wise or column wise. Okay, so but the way it's physically stored on the disk is is defines whether it's column oriented or row oriented. So if we are storing 10 Joe, 12 Mary, 11 Kathy, it is row oriented, right? If we are storing 10, 12, 11 Joe, Mary, Kathy, then it's a column oriented, right? All right. So that was column oriented databases. Now there's something called column family oriented database. Now HBase realized that there will be always a political conflicts with saying that we are row oriented, we are column oriented, and so on. Okay, so HBase took a very clever step. HBase took a clever step in the sense they defined something called column family. Okay, and column family and said that we are column form family oriented database. Column family is a group of columns. If you have and the data in a column family stays together. Okay, so for example, cf1 and cf2 are two column family. In cf1 you have two columns, employee id and name. Okay, these are the two column groups. So when you store data of cf1, it'll look like 10 Joe, 12 Mary, 11 Kathy. Okay, and then once you have finished storing cf1, then you will store cf2. Then it will go like 23, 33, 45. So the data is 10 Joe, 12 Mary, 11 Kathy, 23, 33, 45. That's how the data is stored in case of column family oriented database. Okay, column family oriented database. Now question to all of you is, if there is if there is per one column family for each column, then it is row oriented or column oriented. Anybody? Question to all of you is, if we have one column family for each column, that means that means it is row oriented or column oriented. Anyone? The whole table is column oriented or row oriented. Good, good. Rohit says it's column oriented. That's good. Yes, it is column oriented. If imagine you have CF1 and CF2, it'll store 10, 12, 11, and then CF2 is Joe, Mary, Kathy. Now, okay, now next question to all of you is, if there is one column family for whole table, then it is, okay, anyone, then it is correct, it is, then it will be row oriented. Here it will be column oriented. Sounds good to you? All right, so if we create, say, one column family for the whole table, then what will happen is, inside column family, we go column wise. Like inside column family, we'll say employee ID, name, age, then 10, Joe, 23, 12, Mary, 33, and 11, Kathy, 40, 45. So it became suddenly the row oriented, and it suddenly became the column oriented. Now, do you see the cleverness of the column family oriented database? They can act like both. They can act like a row oriented as well as they can act like column oriented. It is up to It is up to us how do we want. So Rohit's question is 001, 002 etc keys, it is generated automatically? No, these are marked by us. Although it's a good question, I'll take it up after a while when we jump into HBase. Alright, so now let's start with the definition of HBase. HBase is column family oriented database. It is not out of C, A, and P. It is consistent and partition tolerant, but not available. Okay, which means it is like the last one where it's not available. Last diagram like this. It was based on Google's paper of Google's big table and is great only if you are dealing with hundreds of millions of rows or billions of rows. Automatic, it provides something called automatic sharding and automatic reason failover. We'll talk about these details. They are just bullet points here. And it is heavily integrated with Hadoop and HDFS, and it provides massively parallelized processing called MapReduce, and it has a thrift API and all these features. So we'll go into the details of one at a time. All right. So here is the architecture of HBase. Again, HBase is made up of two kinds of servers. One is called master and rest are called region servers. Master, exactly like name node, keeps track of where is my data, while regions store the regions, just the way earlier the blocks of files were stored by data nodes. Here, block sections of table are stored by various databases. So region servers stores region of the table, just like uh, a region is bunch of rows that come together. They're stored in region server. So when you send a request, the first request goes to master. Master finds out what is it that you're looking for and sends you to the region server. And how does it happen? So every table in HBase has got an ID, a unique identifier, and the table is stored in order of this ID. Okay, that means we can always identify the sections of this table based on the range of the ID. So a huge table is divided into rows, and these rows are stored on region server. There are many region servers. Okay, so we store the regions sections of the table and called regions in individual region servers, the way we were storing blocks in data nodes. And this information that which section of the row, which subset of the row is where, is known to master. And this section of the row is defined by initial initial and the end of the row because the data is ordered by the row key. Alright, so each region server stores data in HDFS, and each region server has got hfile, memstore, write ahead log. This is the machinery. Write ahead log makes it possible that when the user is writing to the region server, it parallelly saves it in the disk. Alright, so these are the machinery that makes the region server work, and you as the user can use the API which calls master and region servers. Alright, now a common question arises that how does master keeps track of how many region servers are there? Does master keep tracking all these region servers and then removing them if they have not pinged for some time? So instead of doing that, it uses Zookeeper. Zookeeper is this guy who does the heavyweight lifting of keeping track who is online, who is offline. So everybody who wants to be visible to the network, visible to others, they register themselves to the Zookeeper, and Zookeeper will remove the node in case they time out. Okay, so Zookeeper is making the coordination possible between master and its region servers. So in case one region server goes down, master is not impacted. All right. So that is the architecture of the overall architecture of HBase. Now let's understand what is the reason. Tables are automatically divided into regions. Each region comprises a subset of table rows. Each region is denoted by which table it belongs to, what is its first row, which is inclusive in the definition, and last row. Okay, when I say my region server is from A to B, it means it doesn't have B, but it has A. When I say my region server is 1 to region is starting at 1, ending at 100, it means 99, from 1 to 99, because last row is not inclusive. Initially, initially when you create the table for the first time and when you insert data into it, okay, when you insert the data into the table, there's only one reason which is equal to full table. And as you keep on putting more and more data into this table, this region splits into two regions. This region splits into two regions, and then further the chain reaction keeps on going. Whichever region becomes big after a point of time will again split into parts, and then and that's how that uh, it makes sure that as the table grows, the number of regions also grow, and therefore it's able to do a billion load balancing. And this region is stored on the HDFS. Okay, the reason each region is stored on the on the HDFS. Now question is why HBase is CP, though it can be horizontally scalable. Yes, but as you can see here, the diagram, there is a master. For every user has to go through master to reach to the end user, to reach to the region servers. Therefore, it is it is only CP. It's not A. If there are too many requests coming in for HBase, it may not be able to handle that many requests. Therefore, it's not that greatly available. All right. Now that was so as and when the table keeps growing, number of region servers keeps growing automatically. Now you can see that if our row keys are starting with A up to Z, then a typical server architecture might look like this. Here there are three region servers, 1, 2, and 3, and these are the various key subsets. All right. All right. So regarding the data model, so the best definition of the data model is probably in Google's paper of big table. The definition is it's sparse, distributed, persistent, multidimensional, sorted map. Don't get intimidated by the keywords. The these are very this is probably the best definition of HBase. Why? Because I cannot take out even a single word, and I don't need to add a single word to the definition. These six words define HBase. Starting with map. What is a map? Map is a key value pair and the collection of such key value pair. A collection of key value pair. So it is a big map. Okay. Why? What is the key? Key is called row key. Every row in this database has got a key, and values is multidimensional. Okay. So it's a key value pair while value is multidimensional. And this table is ordered by the key. Okay, unlike the typical map, if you are from data, have gone through data structures, the map is not ordered by by the key, but this particular map is sorted map in which the data is ordered by the key and the value is multidimensional. Now this map is also saved in the disk. Saved in the disk meaning in case the computer goes down, memory gets something goes wrong with the computer, then the data is available in the disk. Data is not lost. Also, it is distributed, meaning some of the keys of this map are going to be on one machine, some of the keys are going to be on another. Okay. And it's distributed and sparse in the sense that all the values don't have to have the same fields. Some of the values can have different name, some of the values can have, so it's like a matrix where some of the columns are empty, some of the columns are full. Okay, so that is the definition of data model. Now going ahead with the further definitions, a table in HBase is basically the biggest unit of storage, and HBase organizes data into tables. Table names should be strings because it will create, while storing the data in the HDFS, it will be using table name as the folder name. Okay. Row is within a table, data is stored according to its row. Rows are identified uniquely by their row key. Okay. Every table has got rows, and every row is identifiable as by row key. Although we have already, uh, I mean, in our normal databases, not every row or not every table has got identifiable primary key. Here it is there. Row keys do not have data type and are treated as byte array, meaning you can store binary data in the row. Now, column family data within row is grouped by column family. It impacts the physical arrangement of data. Okay, so as we have already discussed, that column family orientedness means all the data within the column family will stay together, and it impacts the arrangement of the data. They must be defined upfront. While defining a table, you don't need to define the columns, but you need to define column families. Okay, while defining HBase tables, you don't have to define how many columns it's going to have, but you have to define the how many column families does this table have. Every table must have at least one column family. Okay, so every row doesn't have to store the data in all column families, but the column family have to be defined upfront. Similar to tables, it will be creating a folder for the column family. Therefore, keep the name of the column family something which does not have special characters. Column family should not have colon in the name, because if you cannot create a file name or folder name with the colon. Okay, and also with the name called slash, a special character like slash. Now data within a column family is addressed by column identifier. We have column name or field name where we store the data. Column qualifiers need not be consistent between the rows. Column qualifiers need not be consistent between the rows, meaning one row can have one column, other row can have other columns, and third row can have some other columns, and so on. It's okay to have different columns in different rows. Okay? And again, just like row key, column names are also binary data. You'll be surprised that the kind of data model we go with, we store a lot of data in row key and column names. Okay, and you should also realize that you can do that absolutely. We stored actually the music file earlier in one of my projects as column name. Okay, meaning the whole song was stored as column name in byte array format. Alright, then the last unit is probably the cell. Cell is a function of table, table, column family, row key, column column name, and one more thing called version. Every cell has got three versions by default. You can increase these versions per column family. And what does it mean by versions? Versions are for the situations where you are trying to keep the history of cell. Each cell has history, and that history is tracked by the way of versions. And this is a very important aspect. When we are trying to keep the previous snapshot of some value, you could use a cell's versions. Okay, so values within a cell are versioned. A version number, which by default is the right timestamp at what time we are writing the data, and if you do not specify in the right, the current time will be used. If you not specified while reading, if you do not specify which version do you want, it'll give you the latest one. Okay, the number of versions written by HBase is configured for each column family. Okay, and the default number of cell versions is 3. All right. Now this is something, a visual way of saying what is table and what is row. So you can see this whole is a table containing 6 rows and one, two, three, four columns and 2 column families. There is one column family called personal. There is another column family called office. Personal column family has got 2 columns, name and residence phone, and office column family has got 2 columns called phone and address. Although this table is not sparse, we will see some sparse example very soon. Now, every row is identifiable by the row key. Same thing if you try to represent it like a big structured format. It will be row key followed by column family, followed by column, followed by version, and so on. All right. Rohit's question is, does HBase take only structured data? No, it's for semi-structured data. In every row can have different column names. And also we don't have to define that upfront. So Srini's question is how row key length will be generated. You don't have to generate that. HBase will do that. We don't row keys length is not fixed. All right, let's take a very good example of the data model. That's probably one of the reasons why HBase exists. That's probably the one of the reasons why HBase exists. All right. I think what should I do? All right. Let's try to imagine that you are creating a great corpus of the internet, meaning you are downloading the data from across the globe. So Google used Bigtable for storing the web pages from across the globe. So how would you design that kind of data structure? Let me try to explain that and the reasoning behind every design. Reasoning behind every part of the design. So let me explain to that. Let's imagine that this spreadsheet which you see here is a H-based table. Okay, its name, let's define a name called web table. Okay, now in this web table, let's say we define a column family called contents. Okay, contents. The default one, which is blank, is our HTML content. Okay, and this is our row key. Is it visible to you? And the next column in this column, the next column family we have is say anchor, anchor, and okay, this is our other column family. Sounds good to you? All right. So here is the boundary, and we will try to make a nice boundary. Boundary look really nice. All right. Now here is our row key. So we are trying to store the data from the internet corpus. So here goes our website name, say nobigdata.com. So a Google crawler, or how does a crawler work, is they download a website and its content, and it stores a content like this. Okay, so this is the HTML content. If it has PDF content, then it will put the PDF content here. Then it went to another website called say Hot and Works, hotandworks.com, and then it stored the data of Hot and Works. And also they noticed on our website that we are having a link to hotandworks.com, and I'll say here VM. Okay, so this is what they found on our website. So the crawler, our crawler, whatever we are trying to build, went to nobigdata.com, found this kind of HTML, and then went to Hottenworks. At the same time, it realized that here, let me make one more column here. This is a blank. Okay. Let me just leave it like blank. Maybe here PDF or maybe binary. Okay, and here under anchor we might have who is pointing to who. So it first went to no big data, noticed that there is a Hot and Works link, then downloaded the website of Hot and Works. On Hot and Works they find out that there is a link to Microsoft. Okay, and we call it HD Insights. Okay, then it went to Microsoft.com and then rest. Okay, now coming back to this. The, so so first we downloaded data, put it in the column family called contents in the default column, which is the blank name, and same thing we did for Hottenworks. Also, we did couple of clever things. We realized that Hortonworks is being linked by no big data. We want to keep track of who is linking to who. So the column name we gave is no big data, and we said that no, it's being referred as virtual machine. Okay. Next is that we realize that Microsoft is being referred by Hortonworks. So we put one more column called hortonworks.com, and Hortonworks is pointing to Microsoft under the name Insights. Right? You see Insights here, and VM here. Do you see that? So yes. So now what is interesting to know is as the as the rows are increasing, columns are also increasing. Okay? As the rows are increasing, columns are also increasing. Maybe columns will increase faster than the rows, but we don't know. Okay? Is this design clear to everyone? Yes. So we are creating one column as and when we realize one website is linking to the another. Okay. If here on our website, there is a link to Cloudera as well. We say href cloudera.com, and we mention here that hue is provided by Cloudera. Then we will have here cloudera.com, and it is being referred as hue. Okay, so we are building this big table by crawling the data. Objective of this design is we should be able to save all of the content of all of the websites. Second, we should be able to store who is referencing who. And there is third requirement which we have not discussed yet. We should be able to get the data of all the subdomains. Okay, of all the subdomains, say www.nobigdata.com, blog.nobigdata.com, and say mail.nobigdata.com. So, and similar is microsoft.com, in.microsoft.com, and us.microsoft.com. So we want to be able to get all the data pertaining to these subdomains. Okay, to these subdomains. But since this data is ordered by row key, so if you order it by row key, do you see that? First, record will be blog.nobigdata, then will be in.microsoft, then will be no big data, then will be mail.nobigdata, then Microsoft, then US, then W. You see that? So imagine there are a billion websites, and what will happen? The data will not be ordered at all. Okay, we want the data to be ordered properly so that all the websites of all the subdomains of same website come together. Okay, to do that there is one more clever thing we did here. We, instead of making the row key like nobigdata.com, we will make the row key like this. Okay, we'll make the row key look like this. All right, sounds good to you? So we will do that. We'll make it look like this. Okay, sounds good to you? Now, do you see that? Now, no matter now when you sort the data, when the row keys are stored, the row keys are sorted. Therefore, by default, if we get the hold of first row key, we can crawl down, we can scan down and get all the row keys pertaining to a particular domain. Is this idea clear? So why did we order this row keys like this? Yeah. All right. So this is the reason. This is how we store the data. Also, every time we scan, we will keep the previous records here. That is something I will not be able to do, but just keep in mind that every time we visit a web page, we will keep the past data in the history versions of the rows. Okay, so this was the data model of our table, which was stored, which was for storing the internet data. All right. So also the column family anchor. So if we have to get all the links that are pointing to this current table, all the people who are linking to hotandworks.com, all we have to do is crawl. We have to ask HBase, give us all the columns of the column family called anchor and row key called hotandworks. Okay. So this is the way we will be able to. So this is a very important exercise. It's a very important exercise. Based on this, you have to create a Gmail kind of storage for storing the emails of all the people. Okay, take your assumptions, take your objectives as if you have to build an email system. And the beauty of the today's time is that if you wish to build such kind of storage like Gmail, you can do that using HBase. Okay, so that's how we designed the architecture of this. All right. So a quick guidelines of data model. Indexing is based on row key. Tables are sorted based on row key. Each region of the table has sorted row key space, which is start key and end key. And each region is basically can be therefore identified by endpoints, the limits. Now, everything in HBase table is stored as byte array, whether it's cell value or whether it's column value, whether it's row value, everything is byte array. Atomicity is guaranteed only at row level. No multi-row transaction is allowed. Okay. Column families have to be defined upfront at table creation time. Column qualifiers are dynamic and can be defined at right time when you are creating the data. So column families have to be defined upfront. They are stored as byte array, so you can put data in them. All data model operations return data in this order. First, it's sorted by row key, then sorted by column family, then sorted by column name, then sorted by timestamp, etc. Okay, so let's have a quick look at the HBase. I think HBase works from here. No. Oh, we have only data browser. Don't worry. So yeah, we can say HBase shell. So HBase shell is the interface to the HBase. So here we are trying to see the status. Let's see what's the status. It says all three servers are up, zero are dead. And when we say status, when these three servers we are saying, it means these are region servers. Okay. And next is let's create a table called, here I'm creating a table called my table, and it has got two column families, my CF1 and my CF2, I'm creating a table. It says that the table already exists. Okay, let's create another table. Let's create web table, and first column name is contents, and second column name is column family is, these are column families, not columns, anchors. All right. So we have created this table called web table contents anchors. Now here, if we have to add this row, what will we do? We will say put web table. We're putting this content into the web table, and the name of the row key is what is the row key? Row key is this. Okay. Into this row key, we are putting into this column called contents, and notice the column here. Column is the separator between the column name and column row. Sorry, column family and column field. So column field is empty, so that's why that's empty. Now here we can put our HTML. So you can see scan web table. So it has stored our data. You see that? Now we are storing, let's say, Hortonworks. Okay, Hortonworks. And under content, we are saying this is our content. Sounds good to you? What happened? Oh, and also Hortonworks spelling is wrong. Okay, so now we have stored. Also, please note that there is no, we are not using any query language right now. So we have been able to store this. And now we are saying for this particular column name, add this. For particular column name, add this. Okay, let's try to do that also. We say put into web table. And for this particular row key, what was our row key? Row key. This particular column inside anchor column this. Okay, I'm putting the value as VM. Not anchor, it will be anchors. Alright, now you can see what's going on with this. You see that? We are able to store the way we wish to. Okay. In the same manner, we are going to store Cloudera. We are saying put into web table for the row called hotandwork.com, and for anchor here, sorry, we are, this is not correct. This design is not correct. So here it would be cloudera.com. Cloudera has got some content. We will crawl it later, but right now it's being like this. Okay. So you can see that have been able to do many things here. Okay, we have been able to do many things. Okay, let's say Cloudera also refers to Microsoft. Let's say here, let's say ahref equals to Microsoft.com, and we here it's saying Windows. Okay, then in here you will see Cloudera in the column name also, and then here it'll be Windows. Okay, so this way you can see that we are able to create this data in the following manner. All right, so give it a try. I think this will make it more clear when you do the get put. Okay, that's what is happening here. Get and put. Try this, and then you'll have more clarity on what's going on with HBase. Physically, this is where HBase stores things. Okay, this is where HBase stores things. I'll just show you this. So let me just try to go to this folder. All right, this is where HBase stores things. So it shows apps HBase data default. Inside this, it has created a table called web table. Inside web table, it has created this big number which represents my column family. Inside column family, it has created these column families: anchors, contents, and recovered edits. Okay, you can see that the data is there. If we flush web table, then all the data will be flushed. Okay, so you can see now inside every table, and inside every table is this data for sorry inside every column family is your reason. This is your reason ID. So, and here is your data. Sorry, this is table, then reasons, then column family, then column values. Okay, this is the column value. All right, I hope that gives you a clear picture on what happens. So we talked about many things today. We tried to understand why NoSQL. Before that, we went through Hive, and we also talked about the data model of HBase, CAP theorem, and and how does HBase and region servers work. So, all right, we'll continue from here onwards in tomorrow's session. All right. So Srinivas, are you not able to log in into this? I'm actually wondering if you go here, are you not able to see this? And when you see here, so this is our before yesterday session. I mean, on the last Saturday session. So are you not able to see this video recording? Here in the session number 9, this will be replaced with the newer one. All right. Shashi, I'll not be providing the solutions before the session finishes. Okay. Although we have the solutions, but those were the assignments for you, and the expectation from you is to finish that. We'll be providing solutions only once everybody submits. So it's all right. So it'll be difficult. Is it something urgent? You want the solutions to all the problems? Okay. Yes, Srinivas, it will be provided to you by tomorrow. Not by tomorrow, within like 3-4 hours from now. All right. All right. All right, then have a good day. Thank you very much. Bye bye.